Hello, this will be a demonstration of Proposition 25 from Book 6 of Euclid's Elements, which requires us to construct one and the same figure which is similar to a given rectilineal figure and equal to another given rectilineal figure. We're given two rectilineal figures. We're going to be given the triangle ABC. That. ABC. And some other rectilineal figure D. Again, it doesn't matter exactly what kind of rectilineal figures these are, other than that they are rectilineal figures. And given these, the triangle ABC and the rectilineal figure D, our task is to construct a rectilineal figure which is similar to the triangle ABC and equal to the rectilineal figure D. We're going to begin by constructing the parallelogram BCEL on the straight line BC equal to the triangle ABC. We can do that by proposition 144. This parallelogram is going to look something like that. EL. And we're going to produce this straight line BC in the direction of point F by postulate 2. And finally, in this angle here, FCE, we're going to make the parallelogram CFME equal to the rectilineal figure D. We can do that by proposition 145. That's CFME. So the parallelogram BE is equal to the triangle ABC, and the parallelogram EF is equal to the rectilineal figure D. Like that. Now, because BC is in a straight line with CF, right, we made BF such that it's continuous with BC in a straight line. It then follows that LE is in a straight line with EM. You can do this by a proposition 114 and some other props, but the argument is quite simple. Because BF is a straight line, it then follows by proposition 113 that the angle BCE plus the angle FCE add up to two right angles, right? When you have a straight line falling upon another straight line, the adjacent angles add up to two right angles. So the angle BCE is going to add up with the angle FCE to create two right angles. But we know because BC is parallel to EF, right? Well, BF is parallel to EM, which means that BC is parallel to EM, that the alternate angles are equal. That's proposition 129. So the angle BCE is going to be equal to the angle CEM. And likewise, because CF is parallel to LE, then again follows by proposition 129 that the angle FCE is equal to its alternate angle CEL. But these two angles together, BCE plus FCE, add up to two right angles, again by proposition 113, which means that these two angles down here, which are equal to them, must also add up to two right angles. So the angle CEL plus the angle CEM add up to two right angles, which means by proposition 114, when you have one straight line falling upon two straight lines, such that the adjacent angles add up to two right angles, those two straight lines are in a straight line with one another. So the angle CEL plus the angle CEM adding up to two right angles, LE is in a straight line with EM. Next, going back to the construction, we're going to make the straight line GH as a mean proportional between BC and CF. Say it's about that long. GH. And then finally, we're going to make the triangle KGH on the straight line GH similar to the triangle ABC. That. Now I say that this triangle KGH has been made similar to the triangle ABC and is equal to the rectilineal figure D. I'm going to begin by proving this. Now, because BC is to GH, just as GH is to CF, we made GH as a mean proportional between those two by proposition 613. Yeah, I forgot to explain the props. So we make GH as a mean proportional between BC and CF. We do that by proposition 613. and then we make the triangle KGH similar to the triangle ABC by proposition 618. Sorry, I forget to do that sometimes. I go too quickly. Again, but returning back to the proof. Because BC is to GH, just as GH is to CF, we made GH in that way. It then follows that BC is to CF just as the triangle ABC is to the triangle KGH. That is the porism of proposition 619. If you have three straight lines which are proportional, the first has to the third the same ratio which the figure on the first has to the similar figure on the second. So in this three-term proportion, BC the first, GH the second, and CF the third. The first BC is to the third CF, just as the figure on the first, which is the triangle ABC, is to the similar figure on the second, which is the triangle KGH. So that in total, BC is to CF just as the triangle ABC is to the triangle KGH. But we will observe that BC is to CF just as the parallelogram BE is to the parallelogram EF. That's proposition 6.1. These two parallelograms BE and EF are under the same height, which means they are to each other as their bases, so that BC is to CF just as the parallelogram BE is to the parallelogram EF, which means we have two ratios which are the same with the same ratio, which means they are the same with one another. That's proposition 5.11, so that the triangle ABC is to the triangle KGH just as the parallelogram BE is to the parallelogram EF. But in the first step, we had made the parallelogram BE equal to the triangle ABC, which then means by proposition 5.14 that the triangle KGH is equal to the parallelogram EF. Right, when we have four magnitudes that are proportional, and the first be equal to the third, the second is then equal to the fourth, so that because the triangle ABC is equal to the parallelogram BE, the triangle KGH is equal to the parallelogram EF. But we had made the parallelogram EF equal to the rectilineal figure D. That was our first step, which means we have two things which are equal to the same thing, which means by common notion 1, they are the same with one another, so that the triangle KGH is also equal to the rectilineal figure D, which means that the triangle KGH is both similar to the given triangle ABC and equal to the given rectilineal figure D, which means we have done that which we set out to do. We have made one and the same figure, the triangle KGH, which is at once equal or similar to one given rectilineal figure, namely the triangle ABC, and equal to another given rectilineal figure, namely D, which means we're done with the proposition QEF. I got nothing to say about this proposition. It's rather straightforward. So I'll end the video here and move on to proposition 6.26.